Most Ford owners don't realize how much control they already have over wear, heat, and long-term reliability. The buttons are there, but the consequences of using them wrong aren't explained. The result shows up slowly: hotter drivetrains, stressed batteries, brakes that work harder than they should, and engines that age faster than expected. In this video, we're going through the hidden buttons and habits that decide whether your truck stays in the safe zone or drifts into expensive territory. We'll cover heat management, electrical strain, braking load, and engine protection. Watch till the end, because the last one reveals a chain reaction most owners never see coming. Number 12, the tow or haul mode. Activate tow or haul before pulling weight, watch transmission temperature stabilize, and feel shifts firm up as heat drops instead of silently cooking internal clutches. $4,000 transmission rebuilds rarely begin with abuse. They begin with heat in. One of the most overlooked buttons in many Ford trucks and SUVs is tow or haul mode, and ignoring it while pulling weight is where expensive problems start. Leave the truck in normal drive under load, and the transmission hunts between gears, the torque converter slips longer than it should, and fluid temperature climbs. Once that fluid oxidizes, clutch packs glaze and internal wear accelerates. Engaging tow or haul recalibrates shift timing, increases line pressure, and reduces unnecessary gear changes. Use it anytime you are towing moderate weight or climbing long grades, and check transmission fluid condition every 30 to 40,000 miles under heavy use. An inexpensive fluid service around $180 is far better than a $3,800 to $5,500 rebuild later. There is an exception. Running tow or haul constantly while unloaded on flat highways can reduce fuel efficiency and create harsher shifts. If you want proof, plug in an OBD scanner and watch transmission temperature drop when the mode is used correctly. Gear heat is only part of the story. Electrical strain hides even deeper in modern Fords. Number 11, the auto start and stop system. Disable auto start stop during short cold commutes, listen for smoother restarts, and protect your battery from constant cycling that quietly drains reserve capacity. You were told the auto start stop system is there to save fuel and reduce wear, and in steady driving, it does trim consumption at idle. The part most owners never consider is what constant restarting does to the electrical side of the truck. Every time the engine shuts off at a light and fires back up, the starter motor, ring gear, and AGM battery absorb that load. Over months of short, cold trips, repeated cycling accelerates battery depletion and stresses the starter assembly. If your Ford hesitates slightly when the light turns green or the dash flickers for a split second on restart, that is often early warning. In heavy stop and go traffic with brief commutes, consider disabling the system for those trips. Have the battery load tested at least once every 12 months. A simple $120 diagnostic is far easier to swallow than a $600 to $1,200 AGM replacement with programming. There is an exception. Long highway drives with a fully warmed engine place minimal strain on the system. If you want clarity, use a battery load tester or scan tool to monitor state of charge trends over time. Electrical stress rarely announces itself loudly. It builds quietly. Heat management inside the cabin can create a different kind of strain altogether. Number 10, the AC recirculation button. Press the recirculation button in heavy summer traffic. Cool cabin air faster and reduce compressor strain before pressure. Spikes shorten its working life. If your air conditioning struggles in heavy summer traffic, the problem may not be the compressor at all. Many drivers leave the system pulling hot outside air instead of switching to recirculation, forcing the compressor to work harder than necessary. In extreme heat, that extra load raises internal pressure and increases clutch cycling. Over time, excessive cycling contributes to premature wear inside the compressor and added strain on the system. Engaging the recirculation button during peak heat allows the system to cool already conditioned cabin air instead of constantly battling 90-degree outside temperatures. Use it when first cooling the vehicle and during slow traffic in high heat. Once the cabin stabilizes, return to fresh air to prevent stale air buildup. Spending $0 on proper usage beats a $1,300 to $2,400 compressor replacement later. There is an important exception. In humid or rainy conditions, prolonged recirculation can increase window fog and reduce visibility. If you want confirmation, connect a scan tool and monitor AC pressure readings during both modes. You will often see lower strain when recirculation is used correctly. Small HVAC habits protect more than comfort. Fluid management under the hood carries consequences that extend far beyond cabin temperature. Number 9, the oil life monitor. Change your oil before the monitor reaches 0%, protect internal components early, and keep lubrication strength from thinning under severe driving conditions. That oil percentage on your dash is not a chemical test. It is an algorithm estimating degradation based on temperature, load, idle time, and mileage. The system is smart, but it cannot actually measure contamination or shear breakdown inside the crankcase. Under severe use like short trips, towing, or extreme heat, oil can lose viscosity before the monitor reaches 0%. Waiting until the display reads 0 every time can stretch intervals farther than ideal in harsh conditions. A safer approach in demanding driving is changing oil when the monitor shows around 20 to 25% remaining. An early $70 oil service is minor compared to $3,500 to $8,000 in long-term internal engine wear from neglected lubrication. If you notice loud or idle darker oil early in the interval, or slight ticking on cold start, those are subtle clues the engine is asking for fresh protection. That percentage is guidance, not gospel. There is an exception. Drivers who spend most of their time cruising steadily on highways in moderate temperatures can safely follow the monitor closer to 0. For added confidence, consider occasional oil analysis through a lab kit to confirm condition trends. Lubrication strategy matters, and temperature management inside the cabin can quietly influence electronics just as much. Number 8, the remote window vent. Hold the unlock button to vent windows remotely, release trapped heat before entry, and shield delicate electronic modules from repeated high-temperature exposure. Heat does more than make a truck uncomfortable. When a Ford sits sealed in direct sun, interior temperatures can climb past 140 degrees. Baking modules, screens, and wiring connectors. Many models equipped with global open allow you to vent the windows remotely by holding the unlock button on the key fob. Ignoring that feature means every hot start forces sensitive electronics to endure extreme thermal cycling. Repeated expansion and contraction inside control modules can create microscopic solder fatigue over time. That kind of degradation shows up months later as random glitches, intermittent screen resets, or window switches that work only when they feel like it. Using the remote vent for a few seconds before entering costs nothing. Replacing a climate control module or body control unit can run anywhere from $300 to $1,800 depending on the model. The rehook here is simple. Electronics age faster in heat than engines do. There is an exception. Avoid venting windows remotely during rain or in unsecured areas where open glass could invite trouble. If you want to see how dramatic cabin heat can be, a simple infrared thermometer will show surface temperatures on the dash within seconds. Electrical stress builds quietly. Brake stress, on the other hand, leaves a smell you cannot ignore. Number 7, the auto-dimming mirror. Check that green light on the auto-dimming mirror, reduce nighttime glare instantly, and ease eye strain that slows reactions on dark highways. A surprising number of Ford owners drive at night with the auto-dimming mirror switched off and never realize it. That small green indicator light is easy to miss. yet it controls electrochromic glass designed to reduce glare from headlights behind you. When the feature is disabled, bright light hits your eyes directly, increasing fatigue and slowing reaction time over long stretches of highway. Glare does not damage the engine, but it affects judgment and distance perception. After an hour of night driving with constant high beam exposure, subtle eye strain builds. Reaction time stretches by fractions of a second that matter in sudden braking situations. Keeping the mirror active costs nothing, while a single minor collision can mean a $500 to $1,000 deductible, not to mention higher premiums later. That is a steep price for overlooking one tiny button. There is an exception. If the sensor on the mirror is obstructed or malfunctioning, dimming may not activate properly, so verify the indicator light and clean the sensor area periodically. A quick glance once a month is enough. If you want to test it, shine a light from behind while parked and confirm the glass darkens. Fatigue sneaks up quietly. Brake heat, however, announces itself with smell and vibration. Number 6, the hill descent and engine braking. Select a lower gear or engage descent control on steep hills, share braking load with the engine, and prevent overheated pads from warping rotors. That sharp, burnt smell after a long downhill stretch is your brakes telling a story. Many Ford owners rely solely on the pedal when descending grades, ignoring engine braking or hill descent control on models equipped with it. Riding the brakes continuously converts motion into heat, and excessive heat vaporizes pad resins, reduces friction efficiency, and can warp rotors over time. Using manual lower gears or activating hill descent control allows the engine and transmission to share the load. This reduces constant pedal pressure and keeps brake temperatures more stable. On steep terrain, make it a habit every time you descend, rather than waiting for the smell to remind you. Spending $0 to adjust driving technique beats replacing pads and rotors for $700 to $1,400 later. If vibration appears during braking or the steering wheel shudders at a stop, heat damage may already be developing. That is your rear hook. Small habits prevent big bills. There is an exception. On flat terrain or gentle declines, aggressive engine braking is unnecessary and can reduce efficiency. If you want measurable proof, use an infrared temperature gun after a long descent and compare rotor heat when engine braking is used properly. Driveline stress hides deeper inside the vehicle, and it does not always announce itself with smell. Number 5, the global window close. Hold the lock button to seal every window before walking away, block moisture intrusion, and stop corrosion from creeping into door modules overnight. Moisture is the quiet enemy of modern door electronics. Many Ford models equipped with global window control allow you to close every window by holding the lock button on the key fob, yet plenty of owners never use it. Leaving a window cracked overnight might feel harmless, especially in mild weather, but dew, humidity, and sudden rain can seep into door panels and connectors. Once moisture enters the wiring harness or control module, corrosion begins slowly. Electrical resistance increases, signals become inconsistent, and you may notice intermittent window failure or locks that hesitate. A few seconds spent confirming every window is sealed costs nothing. Ignoring it can lead to a $600 to $2,000 repair for a door module and labor. That comparison alone should make the habit automatic. Small preventive actions protect expensive electronic systems. There is an exception. Not every trim level supports global close, and some models require the feature to be enabled in the vehicle settings first. Verify your owner's manual before relying on it. If you suspect moisture intrusion, a scan tool can reveal door module communication faults early. Electrical corrosion works slowly. Mechanical shock inside the driveline can damage parts in a single moment. If this checklist is helping you see your truck differently, take a second to like the video and subscribe for more practical breakdowns like this. I read every comment, so tell me which Ford feature surprised you most so far. Number 4, The electronic parking brake. Engage the electronic parking brake on inclines before shifting, stabilize the vehicle's weight, and spare the transmission from absorbing unnecessary rollback stress. A heavy clunk when shifting on an incline is not just an annoyance. On many newer Ford models equipped with an electronic parking brake, drivers let the transmission hold the vehicle's weight instead of setting the brake firmly before shifting into park. That small habit transfers vehicle load onto the parking pawl and driveline components, creating unnecessary stress. When a vehicle rolls slightly before the transmission catches, internal parts absorb that shock. Over time, repeated stress can contribute to mount wear and driveline strain. The fix is simple. Engage the electronic parking brake fully before releasing the foot brake on hills and make it a routine anytime you park on an incline. That habit costs nothing. Replacing worn mounts or addressing driveline clunk issues can run anywhere from $900 to $2,500. The difference between free prevention and expensive repair is one button. There is an exception. On completely level surfaces, the load transfer is minimal and the risk is significantly reduced. If you want confirmation, listen for clunking during gear changes or have a technician inspect mounts during routine service. Small stress patterns accumulate quietly. Internal engine systems, however, fail for different reasons altogether. Number 3, the cylinder deactivation. Monitor subtle vibrations during cylinder deactivation at cruise. Maintain correct oil specification and prevent valve train wear from uneven hydraulic pressure changes. A faint shudder at steady highway speed can feel harmless, especially in newer Ford engines equipped with cylinder deactivation. On certain models, the system temporarily shuts down selected cylinders under light load to improve fuel efficiency. The mistake happens when drivers ignore noticeable changes in vibration or sound, assuming every transition is normal. When oil viscosity is incorrect or maintenance intervals stretch too far, the lifters and valve train components responsible for switching cylinders can experience uneven lubrication. Over time, inconsistent oil film strength increases wear on moving parts that rely on precise hydraulic pressure. If you notice new ticking noises, rough transitions, or vibrations that feel different from usual operation, that is your early signal. Addressing oil quality with the proper specification and maintaining disciplined service intervals costs around $80 for an oil change. Ignoring persistent symptoms can lead to repairs ranging from $2,800 to $6,500. That comparison alone should keep you attentive. There is an exception. Mild, consistent transitions under light throttle are part of normal operation and not a cause for alarm. If you want clarity, monitor misfire counts or engine data with a scan tool during cruise. Mechanical wear develops quietly. Turbo systems, however, face a different kind of threat entirely. Number 2, the turbo cool down. Idle your EcoBoost briefly after heavy throttle, allow turbo temperatures to normalize, and stop oil from carbonizing inside high-speed bearing housings. Shutting down a hot EcoBoost engine immediately after a hard pull is one of the fastest ways to shorten turbo life. Under heavy throttle, the turbocharger spins at extreme speed and is lubricated by pressurized engine oil. If the engine is turned off the moment you exit the highway or finish towing uphill, oil flow stops while internal temperatures remain high. That trapped heat can carbonize oil inside the bearing housing, a process often called coking. Over time, carbon buildup restricts lubrication and increases friction inside the turbo bearings. You may begin to hear a faint whining sound, notice rising oil consumption, or feel a slight loss of boost response. Allowing the engine to idle for 30 to 60 seconds after heavy load lets temperatures stabilize and oil circulate properly. That minute of patience costs nothing. Replacing a failed turbocharger assembly can range from $3,500 to $7,500, depending on labor and parts. That is a steep price for rushing the shutdown. There is an exception. During light commuting with no sustained boost, Extended idling is unnecessary. If you want reassurance, use an OBD scan tool to monitor boost and coolant temperatures after spirited driving. Heat management does not stop at the turbo. Cooling system behavior under extreme load carries even higher stakes. Number 1, the drive mode plus overheating cascade. Switch to tow or haul under extreme load and heat. Track coolant trends closely and prevent thermal stress from escalating into irreversible engine damage. Head gaskets rarely fail without warning. They fail after sustained heat that was misunderstood or ignored. Many Ford models offer multiple drive modes, including Sport and Tow or Haul, each altering throttle response and shift behavior. The mistake happens when drivers select a performance-oriented mode while climbing steep grades in high temperatures or towing weight, increasing engine load without considering cooling capacity. Higher load raises combustion temperatures and coolant demand. If airflow is restricted, ambient heat is extreme, or the vehicle is already working hard, localized hotspots can develop in the cylinder head. Over time, repeated thermal stress may lead to head warping or gasket compromise. You might first notice slight temperature fluctuations, a faint coolant smell, or unexplained coolant loss. Switching to tow or haul under heavy load helps manage shift patterns and reduces strain. Monitoring temperature trends with an OBD scan tool provides early insight. Changing modes costs nothing. Repairing a warped head or failed gasket can range from $5,000 to $12,000. Small habits decide big bills, and now you've got the controls in your favor. If this helped, like the video, subscribe for more practical breakdowns like this, and tell me in the comments which setting surprised you most. Your input shapes what we cover next. In the next video, we'll turn these ideas into a simple, repeatable routine that focuses on long-term durability, fewer repairs, and keeping your Ford running strong far past what most owners expect.